It's pretty wild when you stop and think about it. Your circulatory system, it's one of the most amazing engineering feats you'll ever find. It's this massive network of pipes and pumps, all running on some surprisingly simple laws of physics. And today, we're going to decode that masterpiece, all by answering one simple question.
We've all seen these numbers, right? At the doctor's office, on one of those machines at the pharmacy, 120/80. We know it's a big deal for our health, but what is it really telling us about what's happening inside our bodies, second by second? Well, that's exactly what we're going to unpack today.
So, here's our game plan. We're going to start with a fundamental law of physics. Then we'll see how our blood vessels have this kind of superpower to control it. We'll look at how the body is basically a genius at directing traffic, zoom in on the final destination, and then, finally, we'll put it all together to make sense of that 120/80 number. Okay, let's start at the very beginning, the absolute foundation of all this. You might not believe it, but the same rule that makes a light bulb turn on is what makes blood flow through your veins. It's a famous idea from electronics called Ohm's law, but tweaked for fluids. And honestly, it's just this simple and elegant. The amount of blood flow you get comes down to just two things. The pressure difference that's pushing it forward, that's the gradient, and whatever's pushing back against it, that's the resistance. It's this constant battle, a tug of war happening all the time. Let's make this crystal clear with a garden hose. Think about it. Your heart, that's the faucet, turned all the way on, creating a ton of pressure. The water moves because there's high pressure at the faucet and low pressure at the other end. But here's the key. If you squeeze the hose in the middle, you create resistance, right? And the flow at the end slows down to a trickle. Your body is doing this exact thing, just with incredible precision. So, if blood flow is all about pressure versus resistance, which one does the body have the most control over? Well, this is where things get really, really cool. It all comes down to a hidden superpower that your blood vessels have. Your heart pretty much sets the baseline pressure for the whole system, but it's your blood vessels that do all the fine-tuning. By just slightly changing how wide they are, they can dictate exactly where the blood goes and how much of it gets there. This ability to adjust resistance, that's their superpower. And this is where the sheer scale of that control just becomes mind-blowing. Seriously, get ready for this. You think that if you double the size of a blood vessel, you double the flow, right? Nope, not even close. Look at this. When the diameter just doubles from 1 to 2, the flow doesn't double, it explodes by 16 times. Double it again, and it multiplies by another 16. This is not a straight line, folks. It's an exponential curve, and it is powerful. And here's the secret sauce behind it. It's called the power of 4 law. The ease of flow, what scientists call conductance, isn't just related to the diameter. It is proportional to the diameter raised to the 4th power. This is the trick. This is how our bodies can make these massive, sweeping changes in blood flow with just tiny, microscopic tweaks to our blood vessels. Absolutely brilliant. So why does the body need such an insanely powerful and precise control system? Well, it's because it's dealing with a fundamental supply and demand problem. This quote from our source material just nails it. Your heart is a beast, but it simply can't pump enough blood to flood every part of your body at full blast all at the same time. If every single one of your blood vessels opened up completely, your blood pressure would totally crash. So the body has to be smart. It has to make choices. And here's exactly how it does it. Picture this. You're going hard on a stationary bike. Your body knows your legs are doing all the heavy lifting. So what does it do? It uses that superpower. The blood vessels in your legs vasodilate. They get wider. This slashes their resistance and basically rolls out the red carpet for a huge rush of blood. And at the same time, the vessels in your arms, which are just hanging out, they stay at their normal size. It's a brilliant, efficient delivery system. Okay, so we've followed the blood as it gets pumped by the heart and perfectly directed by the vessels. But what is the whole point of this incredibly managed journey? Well, to see that, we have to zoom way, way in to the microscopic level. This is the key takeaway. This entire superhighway system, all the high-pressure arteries and that amazing variable resistance, it all exists for one single reason: to serve the tiniest little local streets, the capillaries. This is the end of the line. It's where the real work gets done, dropping off the oxygen and picking up the trash like carbon dioxide. And the physics doesn't stop here. Right at this microscopic handoff point, there's this really delicate dance between competing pressures. They're known as Starling forces. The easiest way to think about it is a simple push and pull. You've got the blood's own pressure, the hydrostatic pressure, that physically pushes fluid out of the capillary to nourish the tissues. But at the exact same time, you've got proteins inside the blood that create something called osmotic pressure, which pulls fluid back in. Now, in a healthy system, that push is just a little bit stronger than the pull, which means there's a constant, gentle flow of nutrients going out to your cells. Okay, we have covered a lot of ground. We've got the fundamental law, the vessel superpower, and that crucial final exchange. So now, let's bring it all home and finally answer our original question about that 120/80 reading. That top number, the systolic pressure, that's the peak force when your heart muscle contracts and shoves blood out into the system. It's the moment the arteries stretch out like a balloon. The bottom number, the diastolic, is the pressure that's still there between the heartbeats. It doesn't drop to zero because your arteries are elastic and they naturally squeeze back, which keeps the blood moving forward smoothly. It's a snapshot of both your heart's power and the health of your arteries. And this chart really brings it all home, showing the difference between healthy and unhealthy high blood pressure. When you exercise, your heart's output, the flow, goes through the roof. And even though your vessels get wider to lower resistance, that flow is so massive that your pressure still goes up for a bit. That's totally healthy. But with chronic hypertension, it's a different story. Your heart's flow might be completely normal, but the problem is your vessels are always a little too tight, creating high resistance. The system is constantly fighting against itself, and that's what leads to damage over time.
So, there you have it. Your body is an absolute master of physics, constantly juggling pressure and resistance to keep you going. The system itself is basically designed for perfection. Which leaves us with just one question. How well are you taking care of the pipes?